Alright, in this video what I want to do is I want to actually go over some of the partial fraction decomposition problems, and so I want to actually evaluate these integrals. So what I want to do is let's first find the partial fraction decomposition of each function. So we're going to take, in this case, 2x plus 5 over the quantity x minus 4 times x plus 3. And we're going to find the partial fraction decomposition. And so we've already talked about, since these are both linear terms in the denominator, and they're first order linear terms, then this is just going to be a over x minus 4 plus b over x plus 3. And so we just have to find the values of a and b that are going to make this work. And so the usual trick in what we've talked about in class is you take both sides, you clear out the denominators. In this case we multiply by x minus 4 times x plus 3. And so that's going to leave us with 2x plus 5 on the left side, and then a times x plus 3 plus b times x minus 4 on the right side. And these are going to be equal as functions, meaning that they're equal for all x values. And so if we plug in specific x values, in our case negative 3 and 4, we'll figure out what we get for each of these values. So if we plug in x equals negative 3 on both sides, on the left side we get negative 1, and on the right side we get a times 0 plus b times negative 7. And if we plug in 4, we're going to get, let's see, on the left side we get 2 times 4 is 8 plus 5 is 13 equals 7a plus 0b. And so this tells us that our b is 1/7 and our a is 13/7. And what that tells us is that if we want to evaluate the integral, I'm just going to move this down here, but if we want to evaluate this integral of 2x plus 5 over x minus 4 times x plus 3, that's going to be the same as the integral of 13/7 over x minus 4 plus 1/7 over x plus 3. And if we integrate that, we're going to end up with 13/7 times the natural log of the absolute value of x minus 4 plus 1/7 times the natural log of the absolute value of x plus 3 plus a constant as always. And that's it. And that's what partial fraction will do for us. Okay, so that integral became much easier because we were able to split this into much simpler terms. Okay, so that's that. Next, let's look at the integral of 4 over x times x minus 2 times x plus 5. And again, we have first order, so irreducible linear terms in the denominator. When I say irreducible, what I mean is that you can't factor them anymore. And so they're first degree polynomials. And so our partial fraction decomposition, we're going to have 4 over x times x minus 2 times x plus 5. And that's going to be written as a over x plus b over x minus 2 plus c over x plus 5. Clear out the denominators, and we get 4 is equal to a times x minus 2 times x plus 5 plus b x times x plus 5 plus c x times x minus 2. And then we can plug in some values. In this case we have 3 constants, so I'll have to plug in 3 values. And so we're going to plug in x equals 0, x equals 2, and x equals negative 5. And when we plug in 0, notice that the terms with an x in it cancel. So that automatically gives us 0 for those terms. The left side is a constant, so there's nothing to plug in, so we just get 4 on the left. And then here our a term, we're going to have negative 10a. So it tells us that our a term is going to be negative 4/10 or negative 2/5. For plugging in x equals 2, the a and the c terms are going to cancel, and we're going to get 4 is equal to 10b. Assuming I did that right, which I did not. We get, just kidding. So if we take bx times x plus 5 and x is 2, we get 2 times 7, so that's 14b. So that tells us that our b is going to be 4 over 14, or 2/7. And then finally, when we plug in negative 5, we're going to get 4 on the left side. The b and the a terms are going to cancel, and we're going to get, this is c times negative 5 times negative 7, so that's c times 35. So that means that c is going to be 4 over 35. Okay, and that doesn't simplify at all. Now, this means that our partial fraction decomposition is going to be, so this integral is going to be the integral of, so a was negative 2/5 over x, plus b, which was 2/7 over x minus 2, plus c, which is 4 over 35 over x plus 5. And we're integrating that with respect to x, so our integral is going to be negative 2/5 times the natural log of the absolute value of x, plus 2/7 times the natural log of the absolute value of x minus 2, plus 4 over 35, I didn't leave myself enough room here, times the natural log of the absolute value of x plus 5, plus c. Okay, and so finding this partial fraction decomposition really, really simplifies it makes these problems that seem really hard a lot easier, because we're just integrating really linear terms in the denominator. Okay, so that's that. The final example I want to do in this video is a definite integral. So there's two things that are different here. We have a definite integral, and we have a second degree polynomial in the denominator. And so when we do the partial fraction decomposition, what's going to end up happening is a few things. So first, let's do our partial fraction decomposition. So we have x plus 5 on the top, x minus 2 squared times x plus 4 in the denominator. And this is going to be, we already know this is a over x minus 2, b over x minus 2 squared, plus c over x plus 4. And now we have to find a, b, and c. And this will be a little bit different this time. If we multiply both sides by x minus 2 squared times x plus 4, what's going to happen, we're going to get x minus 2 squared times x plus 4. On the left side, we're going to get x plus 5. That's on the left side. On the right side, we're going to get a times, let's see, the one of the x minus 2's will cancel, so we'll get x minus 2 times x plus 4. For the b term, we'll just get b times x plus 4. And for the c term, we'll get, let's see, the x plus 4's cancel, we're left with x minus 2 squared times c. And yep, that's what we get. And so we'll need to plug in a few values. We have three values that we need to find here, a, b, and c, three constants that we're solving for. And so we're going to have to plug in three numbers. Now, 2 and negative 4 are obvious numbers to plug in because they make everything work pretty nicely. But we need to think of some other numbers. And so, of course, 0 seems reasonable. So let's plug in these three numbers. And so when we plug in 2 for x, we're going to get, on the left side, we'll get 7. On the right side, the a and the c terms cancel because they have an x minus 2 term in there. And the b term, it's going to be b times 6. So b is going to be 7/6. When x is negative 4, the a and the b terms cancel. The left side, x plus 5 is 1. The a and the b terms are gone. And then we get, let's see, if we plug in c, if we plug in negative 4, we're going to get negative 6 quantity squared. So that's 36c. So c is going to be, so that implies c is going to be 1 over 36. And then when x is 0, we get 5 on the left. We're going to have an a and a b and a c term here. We're going to get 5 on the left. We're going to get a times negative 8 plus b, which we know is 7 over 6. That's all times 4. Plus c times the quantity negative 2 squared. Okay, and then we can solve for, actually we know what c is too. C is 1 over 36. Good, and then we can solve for a this way. So this tells us that we're going to get 5 is negative 8a plus, let's see, 7 over 6 times 4, that's 4 over 6 is 2/3, so that's going to be 14/3. And then negative 2 squared is 4 over 36 is 1/9. Okay, and so I think it makes sense to write everything in terms of ninths. We're going to have 45/9 equals negative 72/9 times a plus 42/9 plus 1/9. And so what's going to happen is on the right side we'll get, so these two terms will be 43/9, that's 45/9, so this will be 2/9. It's equal to negative 72. ninths a, and therefore a is going to be equal to 2 ninths times negative 9 over 72, or negative 1 over 36. And so we're almost there. Our partial fraction decomposition we just found to be, so this is the integral from 0 to 1. We're going to have our a was negative 1 over 36. That's all divided by x minus 2. Plus b, which was 7 over 6, all divided by x minus 2 squared. Plus c, which was 1 over 36, that was dividing x plus 4. And so what's going to happen now is we're going to get the integral from 0 to 1. I'm sorry, we're ready to integrate. We don't need to write any more integrals. We get negative 1 over 36, natural log of the absolute value of x minus 2, plus 7 over 6 times the natural, no natural logs, times, let's see, negative, going too quickly here. This is 1 over something squared, so it's not a natural log. It's just negative 7/6 times 1 over x minus 2. It's just like integrating x to the negative 2, right? You got negative x to the negative 1. And then the x plus 4 term still has a natural log in it. Okay, so, and that's all evaluated from 0 to 1. And finally, when we plug in 1, we're going to get, let's see, when we plug in x equals 1, we're going to get negative 1 over 36 times the natural log of 1, minus 1 over 76 times 1 over negative 1, plus 1 over 36 natural log of 5. And then that's we're going to subtract from that. I'm way out of room here. We're going to subtract from that negative 1 over 36 natural log of 2. Here's where the absolute value matters, by the way, because this is the natural log of the absolute value of negative 2 when you plug in 0. So I think that's the first time all semester that the absolute value is actually super important. Minus 7 over 6 times negative 1/2, and plus, so plus 1 over 36 natural log of 4. Simplify if you like. Obviously these numbers will be picked a little bit easier so that you have an easier time with the algebra, but that is our final answer here. Okay, so sorry for the algebra mess, but that's the idea. Okay, so we find the partial fraction decomposition that allows us to integrate much nicer, much easier. All right, so that's it for the video.